In this video, we're going to finish Section 3 of the 2018 Official SAT Study Guide, Practice Test 1. So keep in mind that this video is part of a playlist where we solve practice problems for the SAT. If you're interested in this content, go to our channel and access the playlist there. Okay, so let's pick up on problem 16. In problem 16, we're told if t is greater than 0, t squared minus 4 is equal to 0, what is the value of t, right? So keep in mind that this is part of the free response part of the test, and so there's no multiple choice here. You simply have to solve the problem, right, as we have it. And we'll call out a few sort of insights or strategies that you can use to help you out along the way. But for the most part, those will just come up organically as we're solving the problem, right? So there's two approaches to solving this problem right off the bat, right? If we have t squared minus 4 is equal to 0, then we can conclude that t squared is equal to 4, right? And now if we take the square root of both sides, you just have to remember to take the positive and negative square root here. Each of them is a potential candidate to solve this problem, t squared equals 4. And now you need to apply this constraint that t is greater than 0. If we apply that constraint, right, so if we apply this constraint here, then we get that t is equal to 2, right? So this is our answer, right? So that's the first way of solving this problem. And another way to solve this problem, right, is to write that t squared minus 4 is the same thing as t minus 2 times t plus 2, right? We're just factoring that out. And we know that this is equal to 0. And so we know that this expression will equal to 0 if either of these two terms is equal to 0. So again, we can conclude that t is in this set, negative 2 or 2. And again, we'll apply this constraint one more time, right, to say that t has to be equal to 2. We have to pick the positive root. We have to pick the positive solution here, right? So either of these approaches is totally valid. So I guess the first insight that you can think about here is, based on the answer choice, right, based on your scorecard, you can't enter in a negative number, right? So unless the question is phrased in such a way that they're looking for the magnitude of the negative number, your answer will be positive in most cases, right? So that's just something to keep in mind. Okay, so let's go on to problem 17. Right, in problem 17, so I'm just going to draw out this diagram for us really quickly. Right, so we have A, B, C, D, and E. We have X feet over here. We're told that a camp counselor wants to find this length X, right, in feet across a lake represented in the sketch above. The lengths AB, okay, so we're actually given the values of these lengths. So let's read them off, right? So AB is 1,800 feet, right? So this is 1,800. EB was found to be 1,400. BD is 700. And CD is 800. Okay, so those are our lengths, and we should also keep in mind that these two angles, so angle E and angle D, are congruent. And now we want to, like I said, we want to solve for X. So so right away you should be thinking of similar triangles when you have this kind of setup. Now the main thing to remember with similar triangles is you have to identify which corresponding elements of the triangles are similar or congruent, right? So we know that these angles E and D are congruent, and we also know that the angle on either side of B, so ABE and DBC, right, they're opposite angles, and so they must be congruent as well. And so what we have is angle-angle similarity, right? And now what remains for us to do is figure out, well, which sides are similar, right? And so what you can see is that BD, right? So this is the side between angle DBC and angle D, right, that is going to be similar to this length BE, right? And you can see that is because it's sandwiched between these two angles, right? And so this is going to be helpful for us in setting up our similarity proportions, right? And now we want to find the angle, or the side, sorry, that's similar to x, right? So we're looking for the side that's similar to x. Well, x is, well, I mean, you can sort of see pictorial that it's going to be similar to 800, but, you know, let's be a little bit more kind of rigorous about this, right? So you'll see that x is between angle E, right, and angle A. And so remember, E corresponds to D, and A corresponds to angle C. It's our only unmarked angle, right? So we can show by, you know, arguing the placement of these sides relative to the angles, which sides are similar, right? So this is kind of the similarity relationships that I've shown, you know, with this color scheme. So let's go ahead and set up our ratios, right? So we want to find x, right? So we'll just say x, and we'll say over 800, right? So that's DC. Actually, you know what? I'm going to write it as DC first, right? Equals. So we need to find the side in our first triangle, so that's EB, and the corresponding side in the second triangle, so that's BD. Right. So this is our similarity relationship, right? So x DC, EB, BD, right? So at the top we have the big triangle, and on the bottom we have the little triangle. And now let's go ahead and just plug in our numbers here, right? So x over, so DC we're told is 800, right? Equals EB is 1400, and BD is 700, right? So that means that x has to be equal to 1600, right? Okay, so that's problem 18. Oh, sorry, 17. Let's move on now to problem 18. Right. So in problem 18, we have x plus y is equal to -9, and we have x plus 2y is equal to -25. And we're asked to find the value of x. So when you have a system of equations, you know, you basically have two options, right, to solve this. You have elimination and substitution. Now, I've said this in a previous video. I generally prefer elimination. I think that it reduces the amount of algebra that I have to do, but either is valid, right? The main thing to do, and to save yourself some time, is to figure out which variable you're going to eliminate or substitute. So because you want to solve for x, right, it makes sense to eliminate y, right? So you want to manipulate the equations so that you can eliminate y, and that way you'll be left with some expression, some equation in terms of x, and you can solve for x there. So the simplest thing to do would be to multiply this first equation by 2, right? If we do that, right, we have 2x plus 2y equals -18, right? And if we keep our second equation as it is, then we can see that we have the same coefficients of y, right? And so now we can subtract the second equation from the first equation, and we'll arrive at some equation that's exclusively in terms of x. Now, you know, if you're wondering, well, how do I know that I need to multiply by 2? You know, say for example, you know, this were 2 and this were 3, right? Well, what you need to do is find the lowest common multiple of your coefficients, right? And that will tell you how you need to multiply what you need to multiply the first equation, like with which coefficient you need to multiply the first equation, and the same thing for the second equation, right? So in this case, it's very straightforward. Our lowest common multiple of 1 and 2 is 2, right? So we'll multiply the first equation by 2. And like I said, we're going to subtract them. So you'll see the two y's will cancel. And we're left with x is equal to negative 18 minus negative 25, which is 7. Right? So this is how we would solve problem 18. Okay. So let's move on to problem 19. 19 is an interesting one. We're told that in a right triangle, right, the measure of one angle, so one of the angles measures x, and then the sine of x is equal to 4 over 5. And we're asked to find the cosine of 90 minus x. So now this might seem a little abstract, right? You might be thinking, well, geez, like if I have this triangle, which of these two angles can I assign to x? And how do I, figure out what cosine of this other angle is? So to answer the first question, I'm going to, first of all, just give myself some labels for my corners. So to answer our first question, right, we're going to use a little piece of logic that you don't necessarily have to think so deeply for the SAT, but it's good nonetheless, right? The logic goes as follows. Since we're told that one angle measures x degrees, and we're asked to find the relationship between sine of x and cosine of 90 minus x, right? It doesn't matter which angle we assign to be x degrees, right? The reason is that this relationship has to hold true. So relationship between sine x and cosine of 90 minus x must hold true in general. So it must hold true no matter which angle we assign to be x. So certainly it must hold true in the specific case, right? In any specific case. So this logic might not make sense to you right now, but let's work through this, right? Suppose I assign this angle to be x, right? Then what we have is this angle must be 90 minus x, right? Since we have a right triangle. And so sine of x in this case is going to be, in terms of our sides here, right, is going to be BC over AC, right? It's opposite over hypotenuse. And now cosine of 90 minus x is going to be adjacent, right? So in this case, the adjacent side is BC, and hypotenuse remains AC. So you see that they're the same thing, right? And if I had told you instead, let's assign this angle to be x degrees and this angle to be 90 minus x, well, what would have happened, right? So in this case, sine of x would have been AB over AC, right? Opposite over I'll just scroll up. Opposite over hypotenuse, right? And cosine of 90 minus x degrees would have also been, so in this case, 90 minus x is this angle. The adjacent angle is 90, is AB, and then the hypotenuse remains AC. So in either case, no matter what we assign, no matter which angle we assign as x, the relationship that sine of x equals to cosine of 90 minus x, it is true. So, and in this particular case, right, we're told that sine of x equals 4 over 5. So that must mean that cosine of 90 minus x, which we showed is the same as sine of x, must also equal to 4 over 5. Now, if you're interested in why this is true, right, just because we have an opportunity to seek some more insight in what we're doing here, you can there's basically two ways to prove this, right? The first is to look at the unit circle, and I find that this one is a little less satisfying. Oh, it's not unsatisfying in the sense that everything when we're talking about sines and cosines comes from the unit circle, right? It's a little less visually appealing. So how would we go about doing this, right? If we wanted to go look at the unit circle, well, I would make myself a table, right? So I'd have x, I'd have sine of x, and then I'd have cosine of 90 minus x. And then I would look at different values of x. So I go 0, 30, 60, 90, etc., right? And I'd look at the value of this function, look at the value of this function, and show that at each point, for each input, they're the same, right? So that's the first approach. And then the second approach is a little bit more, like I said, visually pleasing, right? The second approach goes is the following, right? So we have cosine of 90 minus x. So this is actually cosine of x minus 90. So the reason that this is true is because cosine is an even function. So we talked about even functions in one of our other videos. So if you if you need a refresher, you can check that out. But briefly, what it means to be an even function is that cosine of x has to equal the cosine of negative x, right? So cosine of 90 minus x has to equal cosine of x minus 90. This is the negative of this, right? And we show that this is equal to sine of x. So what this is saying is that whatever value you have for sine, cosine achieves the same value but 90 degrees sooner. So cosine, right, achieves same value as sine but 90 degrees sooner. So mathematically what this means is cosine leads, so this is what we say cosine leads sine by 90 degrees. And so if you were to actually graph cosine and sine, right? So let me make a graph of cosine and sine, right? So, So let's say we're going to graph cosine in blue, and we'll graph sine in green, right? So cosine of 0 is 1, cosine of 90 is 0, cosine of 180 is negative 1, then back up to 0 at 270, and then we go back to 1 at 360, right? So it looks something like this. And it's periodic. It's periodic, so it continues along this pattern, right? And sine of 90, sine of 0 is 0, right? Sine of 90 is 1. Sine of 180 is 0. Sine of 270 is negative 1. And sine of 360 is 0, right? So we have something that looks like this. So you see that it's the exact same graph as cosine of x, but it's just separated by 90 degrees, right? So I'll just draw my angle markings here. So this is 90, this is 180, this is 270, this is 360. So, you know, this is, I guess, more of a trigonometric property, right? But really, the connection is all to the trigonometric property comes from this triangles, right? This is kind of like a nice nice way to show that sine of x is equal to cosine of 90 minus x. You know, so I didn't intend for this video to become you know, a video on trigonometry. So I think we can leave it there for this problem, right? The answer here is going to be 4/5. Okay, so let's move on to problem 20. So problem 20, we're told that a is equal to 5 square root of 2, 2a is equal to square root of 2x, and now we're asked to find the value of x. So this is one of those problems where you know, it's just a little bit of algebraic manipulation, right? So we're told that a is equal to 5 square root of 2, right? So let's take this and we'll multiply everything by 2, right? So we'll get 2a, right, must be equal to 10 square root of 2, right? And we're also told that 2a is equal to square root of 2x. So that must mean that these two are equal, right? So square root of 2 x is equal to 10 square root of 2. And now we can square both sides, right? So this is going to be 2x. So in order to square something like this, right, this is going to be 100 times 2, which is equal to 200. So that means that x is equal to 100. Right? So you know, if this step isn't unclear, it's just we're just doing this, right? We're squaring that, we're doing 10 square root of 2 squared. So though, you know, we'll square this guy, so that's 100, and we'll square this guy, which is 2. So that's how we get 200 over here. And so that concludes this section, and I think, you know, we'll conclude this video. You know, I'll see you in the next video where we'll pick up section 4 of the same test. Okay, thank you very much. See you there.